So we've looked at our exponent rules, and we've looked at the multiply rule, the divide rule. This x to the negative a is 1 over x to the a, x to the 0 is 1, and then here's a new rule. And sometimes I've heard this called the power of power rules, because this is a power, x to the a is the power, and then you've got another power outside, so it's power of powers. Now, this is an easy thing to see again if you take an example. So this would be x to the third times x to the third times x to the third times x to the third, which would be the same thing as x to the 3 plus 3 plus 3 plus 3, which would be the same thing as x to the 3 times 4, which would be the same thing as x to the 12th. Now, let's take an example of that. Okay, you try this. X to the third to the 5th, what would that be? Obviously, x to the 15th, right? What would this one be? X to the 0 to the 6th, x to the 0 to the 6th. Would be x to the 0 times 6, should be x to the 0, which would be 1. Because x to the 0 is 1, 1 to the 6th is 1. What would this one be? 5x squared y to the 5th to the 4th. Okay, think about that one for a little bit. So just like earlier problems, I break this up into 3 problems. So I go y to the 4th. Y to the 4th, that'd be 5 times 5 times 5 times 5, which turns out to be 25 times 25, or 625. And then x to the squared to the 4th, power of powers, that should be x to the 2 times 4, and y to the 5 times 4. So my final answer is x to the 25th. I'm sorry, 625, x to the 8th, y to the 20th. There's my answer there. Okay, now what about another problem where I've got, say, 2 things embedded? Okay, let's write a problem down here and write along with me. What if you had 3x squared y cubed times 4x squared y to the 4th, and then all of that was in turn squared? Okay, now remember your rules of order. It'd be good to follow them. So we'd want to do the inside of the parentheses first. So we'd want to use our multiply rule right here on the inside, and then we're going to use our power rules. Okay, so stop the tape and stop the YouTube and do it yourself. And you should have got 12 x to the 4th, y to the 7th, 2 plus 2, 3 plus 4, 7, 4. And then we're going to square that. So I'm going to have 12 squared x to the 4th squared and y to the 7th squared, which is then 144 x to the 8th, y to the 14th. I believe that's correct. Let's try another one. Okay, now let's try this problem right here. And again, I'm probably going to have to assume there's like a hidden parentheses right here. Do this multiplication rule first, then do this power rule, and then we're going to have a division rule going up and down. Go ahead and try that. Okay, so you should have got right here, you should have had 18 6 times 3. X to the third times x to the fifth is x to the eighth. And y to the fourth times y to the 20th is y to the 24th. Doing the denominator, 3 to the fourth is 3 times 3 times 3 times 3. Well, 3 times 3 is 9, so 2 9s, so that's 81. X squared to the fourth and y to the third to the fourth. So I have 18x to the eighth, y to the 24th over 81x to the eighth, y to the 12th. So I can take a 9 out of both of these, get a 2 and a 9 there. So I get 2 ninths. X to the eighth divides into x to the eighth, and I have y to the 12th. Here we go. Okay, now let's look at these two problems. According to my negative exponent rule, x to the negative 2 equals 1 over x squared. So these two problems are the same problem. These are equal problems, equal expressions. Now let's try working them. So you'd have 4 cubed, x to the negative 2 cubed, and y to the fifth cubed. And here you'd have 4 cubed, y to the fifth cubed, and x squared cubed. So we'd have 4 times 4 times 4 would be 64, x to the negative 6, y to the positive 15. Same thing here, 64, y to the 15th, x to the 6th. Remember though, x to the negative 6th is the same thing as 1 over x to the 6th. Hence, this is the same answer as this. And let's look at this problem right here, and we'll simply use our rules, these first two rules right here. So we have 3. There's 3 over 1. There could be a hidden 1 there if you wish. X to the fourth. This is a division rule. Minus a negative 2, and y to the negative 2 minus 5. I'm strictly using this division rule right here. And that gets me 3x, a negative is positive, so that's x to the 6th, and y to the negative 7. Or, if you wish, 3x to the 6th over y to the 7th. Now, by starting with this rule, I could have gone like this, and I could have said, well, this y to the negative 2 really belongs down here, doesn't it? So I go x to the negative 2nd, y to the 5th, y squared. And at the same time, this negative 2, if the negative 2 moves the y down to make it a y squared, well, then this must be going up. So that's x squared, and that's not there. So then look what I get. I'm sorry, x squared. So look what I get. 3x to the 6th over 1y to the 7th, or 3x to the 6th over y to the 7th. Same thing. Okay, I'm going to put a number of problems. I'm going to put 5 problems up here, and you see how you do working them. Okay, now try these problems, work one at a time, and then as you go, as you work one, then start the YouTube up again and see what I did on it. See if you get it right. So here'd be the first one. Now let's look at the second one. So I'm taking the fourth power of each of the factors inside. So 4 to the fourth is 16 times 16, or 256. X to the eighth, y to the negative 12th, which then I could move down. 256 x to the eighth over y to the 12th. What about this problem? So just strictly using the division rule, I get this, which would then be 1x to the eighth times y to the negative 6th. And then I'll use this rule, move that y to the negative 6 down, so I get 1x to the eighth over y to the 6th. And finally, what about this last problem? What would you do first? So 10 25ths is 2/5, and then x to the 2 minus 1, because there's a hidden 1 right there. And then 3 minus 2, so I'd have 2/5 x to the first, y to the negative 2. So then I'm going to square that, and I'm going to square this, and I'm going to square this. So I get 4 25ths x to the first, y to the negative 4th, which would be okay. Or you could write 4x to the first over 25y to the negative 4. Finally, let's look at one more problem really quickly before I think I'm running out of time. What if that was to the negative 2? What would you do there? Usually you get 1y to the 6th over 16x to the 4th. Okay, well that's all for this time.